doing binomial theorem day 2. I just expanded number 1 on your homework. You can go ahead and pause the video and write that down, but I'm going to do another one just like it. Okay, so let's do another one. Pencils down. This time it's to the 3rd power. So how many terms do I have? 4 terms. Look at my Pascal's triangle. 0, 1, 2, 3. There's my coefficients right there. 1, blank, blank. I'm going to make this negative because we've got a negative sign here, so you're going to have to go every other negative, right? So 1, blank, blank. Negative 3, blank, blank. Positive 3, blank, blank. Negative 1, blank, blank. I've got a 4x in here, so I just put 4x to the what power? 3, and y to the 0. 4x to the 2nd, and y to the 1st. 4x to the 1st, and y to the 2nd. 4x to the 0, y to the 3rd. Simplify it a little bit more. I get, what is 4 cubed? 64x cubed minus 4 squared is 16, and 16 times 3 is 48x squared y, plus 4 times 3 is 12xy squared, minus, that's just 1, right? So we have y cubed. Questions? Pretty easy? Not too bad, right? Okay. That was yesterday. All right, let's move on to the next one. I will be able to extend binomials using binomial theorem in factorial form and sigma notation.
No.
I will be able to explain to my working partner how to use factorials with binomial theorem. Okay, think you can do that? All right, so these are factorials. Put your pencils down. Yes, please. Okay, 7 factorial simply means 7 times 6 times 5 times 4 times 3 times 2 times 1. Answer is 50, 40. 11 factorial. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay?
Yeah.
Okay. Now, let's try this. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. But wouldn't it just be easier if we just canceled right away, right? So we'll do that with the next one. Hold on, hold on. So I have 20 times 19 times 18 times ... right? Because 18 factorial is going to go on ... and these just cancel each other out. It's just 20 times 19. Okay? Yes, Mitchell?
Instead of writing out 20 times 19 times 18, you just write 20 times 19 times 18
You could. Yeah, you could just, Evan, stop. Right? That's another way you could write it. Everybody's getting the idea? Because this is not what we're going to do today. We're going to do more of this, but it's not that hard, and it's only a piece of what we're doing. So stay with me here. So on this one I have 8 factorial over, which I'm going to write out 1 second. Isabel. 8 times 7 times 6 factorial, we could stop there, right? Over, I'm going to switch it around, 6 factorial 2 times 1. Everybody with me? 8 factorial is 8 times 7 times 6 factorial, instead of writing it all the way up. And 6 factorial is 6 factorial, and these are going to cancel. Correct? And then 2 factorial is, guys, you're so easily distractible. This is important, okay? 2 factorial is 2 times 1. The 2's cancel, and I'm left with 4. So the answer is 28. Okay? Let's try another one. 8 times 7 times 6 times 5 over 5, and 3 times 2 times 1. This cancels. 3 times 2 cancels because 3 times 2 is 6, so my answer is 56.
What if you were to like swap in 3 with the 62 with the 8? Would that be wrong?
No, it's not wrong. You get the same answer. It makes it more complicated. It's easier if you can cancel. If I would have done the 2 with the 6, there would have been a 3 left over, and if I would have done other way around, 3 with the 6, there would have been a 2, and the 8 with the 2 would have been a 4, and 4 times 2 is 8 times, you know, you're making more work for yourself. But if you didn't see it right away, you wouldn't have got it wrong. Okay, I have to move on. No, you don't need to copy that down. It's embedded in what we're going to do today. Okay? All right, so let's compare. Pencils down. I'm going to do number 3 on your homework. I'm going to do it in binomial form like you did yesterday with Mrs. Watkins. Then I'm going to do it in factorial form, which is easier. Okay? Got it? Okay. Okay, so yesterday you always start with a 1, right? And then m to the 4th, n to the 0, correct? We've got a minus sign here, so we're going to have to go positive, negative, positive, negative, positive, negative. So I'm going to put minus. And then the second one is you just take that, whatever the power is, and you put it over 1. Then m to the 3, n to the 1, plus 4 times 3, you go 1 less. And then you, on the denominator, you go 1 more. I'm hoping that you did this last night, but half of you probably just pretended. Right? Minus 4 times 3 times 2. See what's happening here? 1 times 2 times 3. M to the what? First, n to the 3rd, plus 4 times 3 times 2 times 1 over 1 times 2 times 3 times 4, and we know we're done because m is to the 0 and n is to the 4th. When all of that cancels out, you get that, right? If I were to do all the work and cancel everything. Okay, here's factorial form. Ready for it? Alrighty. So I always start with whatever the power is. So I have 4 factorial over, see, the m is going to be to the 4th, right? So 4 factorial, and the n is going to be to the 0. 0 factorial. 0 factorial is always going to be 1, right? So then m is to the 4th, and n is to the 0. What I like about this one is it's always 4, and it always tells you what the numerator has to, the denominator has to add up to. 4 and 0 is 4. And not only that, but the 4 and the 4 match on the n, and the 0 and the 0 match on the n. Minus 4 factorial over, now it's going to drop to 3 and 1. That means m must be 3 and n must be 1. Plus 4 factorial over, oops, that's not m, 2 factorial, 2 factorial, m squared, n squared. Isn't this easier than this? Minus 4 factorial over 1 factorial, 3 factorial. It takes a couple times and you guys are going to be like, this is super easy. Over n cubed plus 4 factorial over 0 factorial, 4 factorial, m0 n to the 4th. Now, so these cancel. So that just ends up being 1, just like that one was. If you were to write this out, it would be 4 times 3 factorial, correct? The 3 factorials cancel, and you're left with 4, just like you did up here. This one, you're left with, if you cancel the 2 factorial, you're left with 4 times 3, right? Because it's 4 times 3 times 2, but the 2 cancels with this 2. Now you're left with 2 times 1, or just 2 times 3, which is 6. Just like this one, this cancels and it becomes 6. This one is a 4. This one's going to be the same as this one, right? The 3 cancels with a 4 times 3 factorial, and you're just left with 4. And these cancel and you're left with 1. So the same as up here, the same as here. Okay, now, Evan, question. No, you can't just use a triangle because this is going to lead into what I'm going to show you next. Okay? Yes, please write that down. Okay, so let's give it a try. Do you guys want to try it, or do you want me to write it out? Okay, try it on your own in a minute. I will do it for you. Okay, let me start it for you. So if we're talking 3, right, I'm going to start with 3 factorial, and every time I do something, it's going to add up to 3. So 3 factorial, 0 factorial. Then 4x has to match that first part of your denominator, which is 3, and 5y has to match the other part, which is 0. See why I wanted you to write out the zeros? Because they help you, right? Because there's a pattern. Okay, plus 3 factorial over, what is, it's going to drop now, right? It's going to go to 2 and 1. And whatever 4x, it has to match it. That's going to be squared. And 5y is going to be to the first power. The top one never changes. Always stays the same. 3 factorial. I like it because it's like you never forget what you have to add up to. It always has to add up to 3. Always has to add up to 3. So now this next one's going to be 1 factorial, 2 factorial. 4x will be to the first power. 5y will be to the second power. See, it's not that bad, right? Plus 3 factorial over 0 factorial, 3 factorial, 4x to the 0, and 5y cubed. You guys want to try and get to the rest of it yourself real quick?
No.
I have enough of you saying it. Okay, so what I want you to think about when you do this is all one term. This is all one term. This is all one term. And this is all one term. Because I know it can get kind of lengthy, right? So these cancel. Are you guys ready for me to do this? So these cancel, and you just have 1. 4 cubed is 64. X cubed, and I don't have to worry about that because it's the 0 power. Plus 2 factorial, what gets canceled? This is a 3 and a 2 factorial, so that gets canceled. I'm just left with 3. Let's put the plus there and like do it in the middle here. 3. 4 squared is 16. X squared. Am I answering your question, Evan? 5y. Plus, let's do this one. What would be left over here? 3. 4 times 4 times x times 5 squared, which is 25 times y squared, plus, what's left over here? Nothing, 1, times nothing there, that's 1 also, times 5 cubed is 125y cubed. Right? So if I put that all together, I should be putting equals here, and equals here, and equals here, 64x cubed plus, what's 16 times 3 times 5? 240?
Yeah.
That sounds right. 240 x squared y plus, well, 4 times 25 is 100 times 3 is 300. 300 x y squared plus 125 y cubed. Questions? Are we good? Not too bad? Ready for me to blow your mind one more time? Do it. Just a little harder. Put your pencils down. Just watch this, okay? I'm going to do 2 of them with you. Okay, what I'm going to say is going to sound it's going to look kind of like what that formula was in the book, but then I'm going to make sense of it. Okay, so just hang in there with me. So, a second term in the expansion of a minus b to the 3rd power. So I have n equals 3 sigma. It says, write the expansion in sigma notation and find the indicated term. So when we do this, the first one would be 1, because we know it's always 1 in the beginning, right? 1a cubed b to the 0, correct? And then it would keep going from there, right? Then we have our pattern. Well, we know if n is 3, we've got to call 0 something. So I'm going to use k. K equals 0. Right? That's what that means right there. You okay so far? It's always going to be 0. Okay? Because this one's always going to be 0. That first term is always, that second variable is always going to be 0. Right? Okay. Then, whenever I'm working with 3, what's my factorial on the numerator? No. When I'm working with the 3rd power, what's that factorial in the numerator always going to be? 3, right? If it's 3, it's going to be 3 on top. If it's 4, it's going to be 4 on top, right? So this is going to be 3 factorial over, that's where it gets scary. It's not that scary though, and I'll explain in a minute. 3 minus k times k, I don't really need the parentheses there, times k factorial. This needs a factorial too. Hold on. Don't. Whenever you interrupt, you're interrupting other people's thinking. Okay? So 3 factorial over, in this case, it would be 3 minus 0, right? And k is 0. All right, moving on. Then we always know that whatever this term is will be to whatever this is right here, right? So that's going to be 3 minus k. And whatever this one is, which is our b, in this case it's negative b, correct? Negative b to the k. Okay, I know it looks crazy. Let's just think about it in terms of this problem. And then you're going to be like, really, that's not that bad. Okay, so if I want the second term in the expansion, isn't the first term always 0 and the second k is always 0? what's the second term going to be? And the third term? Okay, so if I want the second term, k is going to be 1 less than whatever this is. Correct? Does that make sense? So if I said a minus b to the 5th, and I wanted the 4th term, what would k be? It would be 4. Right? 0, 1, 2, 3, 4. Right? Okay. So, let's fill this in now. So, if I have, I'm using this up here, correct? I'm just going to go straight into it. So this would be 3 factorial over my second term, k equals 1, correct? So 3 factorial, what is 3? It's the second term of the expansion, right? If you're expanding a binomial that is to the power of 3, aren't you going to have 4 slots? Right? This one's going to be to the 3, 0. This one's going to be to the 2, 1. This one's going to be to the 1, 2. And this one's going to be to the 0, 3. Right? So in the second term, k is 1. Got it? You see it now? All right. So that means that this whole 3 minus k thing, it just means I'm not even going to do that first. I'm going to put what k is. What is k going to be? 1. If k is 1 factorial, what does this have to be? 2 factorial. That's all you really need to do. So you write out this craziness up here, and then you just use it. So then if this is 2 and 1, then what is a? 2. And what is negative b? 1. Equals, what cancels here? So what are we left with? 3a squared b, but it's going to, because that b is negative, there's your answer. Okay. Write that down. Let's do another one, and then you'll say, that really wasn't that hard. Okay? All right, let's try another one. All right. Do you want to try it yourself?
No.
Okay. So, I'm going to do sigma. What does n equal? 4. And what does k equal? 0. If I want the 4th term in the expansion, right? If I want the 4th term, what is k going to be?
Y.
Okay. If you have a 4-term expansion, Evan, how many terms do you have? 1, 2, 3, 4, 5. So in the 4th term, what is k going to be? 1 less than the 4th, it'll be 3, and this one will be 1. Got it? So if I say the 4th term, you just subtract 1, and your 4th term is going to be 3. Okay? The reason is because the first one's always going to be 0, 1, 2, 3. See that? So if I want the 22nd term, what would k be? 21. Got it? Okay. All right, so the 4th term, k is going to be 3. So I have what factorial on top? 4 factorial over 4 minus k. It will be 1, right, Evan? It'll end up being 1, but we're going to say, this is the formula, 4 minus k factorial to the y 4 minus k, and 2x to the k. That's the hardest part, right?
So what's K to be put in terms of K? What's the K?
There's,
K to bring K to
they're all the same. We haven't plugged k in yet.
K equals, it was just saying where you start.
What is the last number?
2x to the k. I'm going to change my ways right now. You ready for this? No? I'm not going to require you to do all that. Let's do this. No, just leave it like that. Just follow me, okay? Because I'm not big on formulas about what they mean, right? So this should be 4 factorial over, if k is 3 factorial, what's this one going to be? 1 factorial. Then that would mean y would be, what? 1, and 2x would be 3. Easier? Much easier? The only problem is you're going to have to remember how to find it, k equals 3, and then you're going to have to put the 3 first, and then the 1, and you've got to put it in order so you remember, right? K has to come second. Make sense? Yeah? So now it makes this problem pretty simple, because you have 4 factorial over 1 factorial, 3 factorial, y to the 1, 2 to the 3rd power, which is 8, times x cubed, which is 4 times 8 is 32. 32x cubed is your answer.
Where's the Y?
Oh, I forgot the y. Thank you. 32y.
How do you get 32?
I'll show you right now. 32yx squared. Does everybody agree this would be 4? Hold on. Cubed. Keep making straight. This right here is 4 times 3 factorial, correct? The 3 factorial, I'm going to change the color. This is 4 times 3 factorial. The 3 factorials cancel. You're left with 4 times 8, which is 32yx cubed. Follow? Evan? Yeah? Okay.
But why don't you have to go all the way down to 1 from the 4?
Because it wants only the 4th term. This is not asking you to expand it. It's asking you, you've got 5 slots. 1, 2, 3, 4, 5 slots. This one's the 4th one. Without doing all the rest of it. So it seems like a lot of work, but it really isn't. It's a shortcut.
How do you find K?
Okay, so do you agree that y would be 1 and x would be 3? So here, y would be, what? 2, and x would be 2. And here, y would be 3, and x would be 1, and y would be 4, and x would be 0. So if you're talking in the 4th term, right, 0, 1, 2, 3. And it'll always work like that. It'll be 1 less than whatever one you want. Because you always have to start with the term being 0. Does that make sense? No. Yes, the term minus the
Say you're looking for the 5th term, that's K over
4. If you're looking for the 50th term,
maybe 49.
yep. Got it?
Yeah.
So what page are you on?
can I skip this stuff a little bit to get my right stamp page? Because I didn't get the last 3 years. Well, it takes